All right. So we're going to be talking about, actually, we're going to be talking about finding the equation of lines. So the funny thing is finding the equations of lines, it's a fairly broad topic, but with most of linear equations, we only are going to ever need three different equations or three different formulas. And the first one that we're going to use is the slope formula. Now the slope formula is this: slope is equal to that y2 minus y1 over x2 minus x1. This is because we always need two pieces of information whenever we're finding an equation. We either need 2 points, and if we've got 2 points, we're still going to need this slope. And the other thing is, if we're given 2 points, we're going to have to use this. Otherwise, we're going to need a slope and a point. So actually, the point slope formula. And this one right here is my go-to for a lot of our equations. And this one is y minus y1 is equal to m times x minus x1. Here, when we're substituting in, you only are going to substitute in our point, so our x1 and y1, and the slope, hence the name, point slope form. And the last one is probably the easiest one to use if we're given these pieces of information. And this is, of course, the slope-intercept form. And this one is usually what a lot of folks think of when they think of finding an equation or what a linear equation is supposed to look like. They think of this y is equal to mx plus b. So this is for points. So whatever we're doing, this is given points x1 and y1 and x2, y2. So this is our points that we would plug in to find our slope. Point slope, if we're given just any point, x1 and y1, then of course our slope is m. Or if we're given our slope and our y-intercept is 0, b. So this is the information. So we're usually given 2 pieces of information, and that's enough to find the equation of a line. If we're just given a slope, we plug this in, and then we can either use these two. If we happen to be given our intercept, we can use this. So let's do an example. Let's start with, I'm going to start by giving us the equation of a graph. And the nice thing is graphs, in some ways, graphs are great because they give us a good visual interpretation of things, but they don't always seem like they're giving us, they don't always seem like they give us the information we want. But I'm going to tell you right now, if you know what you're looking for, it can be awesome. So I'm going to say, here is what we have on a graph. And right away, I'm going to show you that here you can, rather than do a long, lengthy calculation to find our slope, you can do things like literally just count out your slope. Remember, slope is is rise over run. So here, between these 2 points, I could say, oh, between these 2 points, this is going up 2 and over 4. So here, my slope would be rise of 2 for a run of 4, or this is equal to just 1/2. Now, if I were to use that slope formula and just plug in those same 2 points, I would still capture this 1/2 as my slope. And to do that, I'll just show this. Here we've got, looks like this is -4, 2, and 0, 4. Or actually, whoops. Oh, sorry, that's a 3 for my y, and that's a 5 for my x, for my y here. So that's a 3 and a 5. If I were to just separately do this using our formula here, that's a 5. I could say, oh, well, this is my y2, so it's 5 minus 3 over 0 minus a -4. And sure enough, that's going to be 2 over 4, which is still that 1/2. And off of here, notice that one of the points I'm given is my y-intercept. This is 0, 5. So I can plug into my y is equal to mx plus b. And it's always the point that is on the y-axis. I can't use this for my y-intercept, but I can use this one. My y-intercept here is going to be 5. So when I write this is just going to be y is equal to 1/2 x plus 5. And we're done on this example. Now, let's do another one, only this time I'm not going to be as nice. I'm not going to give us a y-intercept. Let's say we've got an equation, or we've got a graph and I'm going to find, let's see, I'll do a point right here, and I'll do a point over here. And let's see. Wow. Oops. Didn't mean for that to get quite so messy. So here I could still just count to find my slope, or I could use that point slope formula. It's best not to do things like eyeball where your y-intercept is. Although I think I was nicer than I'd intended to be. So when I look at this, I'd have to say, oh, this is going to be, looks like this point would be 1, 2, 3, 4, 5. So I've got -5. And then 1, 2, 3, 4, 5. Yep, I was nicer than I meant to be. -5, 5 for this first point. This point down here looks like it's going to be 2, -2. Yeah, this I much nicer than I meant to be, because this would be a fall of 7 for a run of 7. So my slope here would be, this would be down 7 for a run of 7. So -7 over 7 is just equal to -1. That's my slope. And this does show one of the ways that we can use it. This still is going to be useful because I'm not given what my y-intercept is. We're going to have to use that point slope form. You can use the y equals mx plus b, but I don't want you to overuse that formula. It's not going to be the best tool for all of these. And we can choose either one of these points. I'm going to choose to use this 2, -2 for my point. And when I substitute in, remember, I'm just putting in this value. So this is going to be y minus that -2. My slope here is -1. And then I've got x minus 2. So notice that we're only putting in the point and the slope. We're going to leave the x and y without a subscript alone. But now I can go ahead and simplify. So this is going to be, well, this is going to end up being y plus 2. I always like to resolve that sign. And here I can distribute this -1. So I've got -1x plus 2. And and now I can actually subtract 2 from both sides. So I've got y is equal to -x, actually just -1x. So this one is a little bit tricky because this one goes straight through the origin. This one goes right through 0, 0. So my y-intercept is literally at the origin. All right, that's all I'm going to talk about for this one. I'll give us some more examples later.